Okay. Right, so we're all on board with shallow v deep, but agree that the exact termination of shallow v deep is a slightly counterintuitive way to have referred to it.
Yes.
Okay. Right. Has a versus is a relationships. So how would each of our dice refer to one another, and how would the cup refer to each of the dice with these two relationships? Yeah, go ahead, Bill.
No, I was just thinking, isn't this like a design question? I know there's an acronym for this. Basically, like if you have an item of arrays or an array of items, that's probably not the exact same thing, but there's like, yeah, it's a, sorry, I'll just mute my kid and myself. Go ahead.
Yeah, so I kind of thought of it basically, this is something you decide when you set up your objects. So, you know, cup is not a subclass of dice. Dice is not a subclass of cup. The relationship between the two is that, you know, two dice, they are a dice, whereas a cup is not a dice, but it does have a dice inside of it. So this is how I had kind of determined each other.
Yeah.
Okay, so then he sets up this very simple dice class. So first we import the random because we want some random number generation. We define our class, calling it by class, MS dice. We put our document string. Usefully here, we give it like a little bit of information. We tell it what variables are going to be included in each instance, which is going to be useful later on if you're trying to remember what your object has, what it does, etc. And then we have our important initiation class, which takes as its first argument, as all of these things do, they take as their first argument the self object, which I found very confusing the first time I learned object-oriented programming, and I did not get, and it took me forever, but I'm slowly getting like used to seeing it now. So the first argument is always the self, and then you have the number of sides, and this is our constructor. So we then say self number of sides is the number of sides, and then we set our current value to be a random roll, which is called in this way, which is self.roll, because roll is a function or a method which belongs to the class of dice, which we are going to define in this next couple lines, where we define roll. Self is the only input here. And what this is going to do is it's going to set the current value to a random number between 1 and the number of sides plus 1, because Python starts counting from 0. So you have to add that plus 1. And then what we do is we return the current value, which we have now just set to be this random number. So we create a new dice object like this, msdi6, because this is our initializer, this 6 here. And then we can basically roll the dice 5 times. And we make a list of 2 different dice. So first of all, because we didn't define a pretty print or a pretty rep method, when we do this print, we get this very kind of ugly thing, which is we get the object printed out, which is just a memory address, which is what this string here is. And then we get the roll, da, da, da. And then when we print our list of a 6 and a 20-sided dice, we get this horrible blah, 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 blah. Okay, so that's not good. So next, what we want to do is actually define these string and rep methods. So as far as I understand, I'm going to say this, and I didn't Google it, so somebody tell me when I'm wrong. String is what happens when you call print, and rep is what happens when you like evaluate the object in an interactive way.
Yeah, pretty much.
Yeah.
So okay. Dunder stir is basically when you convert the thing to a string.
Oh, yes.
So
That
you
makes
can
sense.
also just call string like str on the
Yeah.
object.
And you can also call
yeah.
wrapper on any object, so you get the representation. So basically, Dunder wrapper is for the developer, you or someone else, and stir is the fancy presentation of the object,
Mhm.
kind of. Yeah.
Okay. So now we make 2 dice. We make a 6-sided die and a 20-sided die. We roll it a bunch of times. Now we get pretty printing. And when we print our list of dice out, we get M die 6, M die 20 shows 15. Okay. 2 die will be shallowly equal when they point to the same instance. So this was my example. So if I say something called my die, I send it to my die 6. I can print it out, it's 6. I can basically assign my dice copy to be my dice, and then I equivocate them. And yes, we find that this results in true. So they're currently shallowly equal. Yes, no.
Yeah, I
I
think.
mean, yes,
Yeah.
but if you do my die is my die copy, do you get true as well?
My die is my die copy. True.
So they're the exact same.
They're the exact same.
Which
And
is
Oh,
correct, and we call
Yeah.
it shallow, but it's still confusing. But yes, it's correct.
Okay. But we can't make anything be deeply equal yet because we haven't defined that Dunder method for deeply equal. I just learned today that it was called Dunder method. Actually, when I was Googling all of the methods, I was like, oh, that's easier than what I was saying in my head.
Yes, definitely.
Okay, so going back to our dice class. I have also defined this little function here, set value, because I didn't want to roll the dice a bunch of times. I wanted to just force a value. So we define an equal dice, a dice to be equal to one another. And this was the design question I had kind of before. And I decided that 2 dice would be equal to one another if their faces were the same. So I didn't really care if they had the same number of sides. I decided for my game, of whatever game I'm going to build, 2 dice are equivalent to one another when they show the same face. So basically,
Sounds reasonable.
yeah, it sounds reasonable.
Hmm.
The equivalent function here takes in self and other die. And it just essentially says, you know, get the current value up, get the current value from self, get the current value from other die, return whether or not they equal. So again, I make 2 dice, die 6, die 15. I make a new d20. I roll it. I set its value to 5. I set my die equal to 5. So they're now no longer printing. Oops, they're no longer pointing to the same object, but they do equal one another. So that's kind of it for this chapter 2. And Yannick, if you finish the implementation, please take over screen sharing and show us what you did.
All right, yeah. Share screen. I think you should see my studio window now. And so I have the same MS Die class. The only thing I think I did differently is maybe the string method, in my case, just shows the current value, because for the most part, this is what I care about when I'm talking about a dice. And the representation is, I think it's the representation he used in his example. And then I defined equality and also less than. And I also tested that when you define less than, not only do you get less than, but apparently greater than is then also implemented in terms of less than. So we don't need to define greater than. We can just use it straight away.
That makes sense. That is why you only need to define less than.
Yeah, I didn't check in the documentation. I just tested it. Maybe you can also define greater than, and then it uses the other, like the opposite of this for less than. But less than definitely worked.
Okay.
So this is the minimal set you need for comparisons, I suppose. Equal and less than. And then I assume you also get greater equal or less than or equal, because those two can be combined. Maybe we could check this in a while. And then he said, let's implement a cup of die. And I said, for a cup of die, we need, well, of course, self to init. And then dice, I assumed to be a list of dice. So a list of dice. This is the plural, right? So I'm checking, is that something you're giving me? Has it a length of 0? If this is wrong, I say, no, it needs to be something that at least has a length that is not 0. And then for everything in this list, which I'm assuming is just anything you can iterate over, I'm checking if it is actually a die. And if it's not an instance of die, I raise another arrow. And if everything here doesn't fail, if it just goes through, I just say self.dice is dice. So in this example here, for example, down here, we say cup 1 is a cup, and then we supply a list of dice, yeah, and then we get a cup. And cup is printed like this because I implemented the string method here, and the representation just calls the string method again. The string method of the dice list. We can also ask how many dice are in the list or in the cup by using len. So we should be able to say len cup 1. Yes, that's good. And then for the purpose of this example, I said a cup of die is less than another cup of die if we take all values of the die in one cup. So we take the list of die in one cup, in the self cup, and then for each die in there in this list, we say we take the current value, and these current values are then summed, and then we compare the sums. This is one way to define a cup being less than or equal than another cup. So now we can say cup 1 less than cup 2. In this case, it's false.
Cool.
Yeah, makes sense. And we can also use set item and get item to change individual die. So right now, if we look at cup 1, the first die is 4. But if we say cup 1, it's Python zeros die, and we set it to 1. Now, if I run it again, it's 1. Oh, this shouldn't have worked this way. Something is.
Yeah.
Wait a second.
Yeah. So you're allowing the list to be any value once it's been created.
Yeah. Oh, this shouldn't be.
Yeah. So
Yeah,
we
okay.
would want to like set up basically something that would either access the item itself first and then reset it.
Yeah, this get item and set item, they need to
Yeah.
actually create an object of class die again and not just make the value.
Can you just, yeah, can you just like get the die, because you should return the die and then you can call method or just like change it. Yeah.
We can even cheat because this is Python and everything is mutable.
No, definitely not. Yeah, I get what you mean.
Yeah, it works. Okay, yeah. Well, not everything, but a lot of everything is mutable by default.
No.
And we can also use the roll method to just roll every die in the cup.
But you can change every attribute property of a class like that. You can basically accidentally overwrite built-ins, and it can be completely crazy if you don't know what you're doing. Yeah. I've seen so many people overwrite the list constructor. because they want to have a example list. So they do list equals and then a
You
list,
mean like
and then
this
they
one?
come.
Or the other one?
Or you can say list equals and then,
Right.
I do list and then equals, because list right now is a function that creates a list. But if you use it as a variable, you overwrite the list. You make a point to your new
Yes.
list instead,
Now that
which can
you're,
be quite
you can
confusing.
do it with len too. I've done that to myself before with len.
now that
Yeah.
you're talking about it, in
And
our
stir.
functions and like things like variables exist in a separate namespace. So I could have a list that is just one, and I can still use the function list. But this is not true in Python?
No, it shouldn't be, because you have the built-ins in the global scope, and then you have different modules.
It says object of, okay, int is not callable.
Yeah.
Right, so there's no separate namespace for variables and functions.
No, not per se, but you do have different modules in the standard library, which you can import. But it's like you have quite a few built-ins, which you accidentally tend to override every now and then, especially when you're new. And it can be very hard to debug because you really don't know what's going on. It's like...
Cool. The other thing that was not implemented here that I really wish I had spent time remembering how to do is the idea of making things private and public. I think that's at one point he was also going to explain this and how that's done in Python.
But you didn't, right?
And
it's not.
He didn't. No.
It's not really done.
Yeah.
So
I was trying to Google it.
Yeah,
So
Python has
double
the
under, right?
Yeah.
It's just a convention.
You have the single underscore for protected. It's please don't touch this. Something would probably go wrong. And then you have double underscore, and then it's name mangled. You can still access them, but you'll have to go through some hoops. But basically, Python uses the paradigm of we're all consenting adults here. So you use single underscore prepended attributes to your attributes as a don't touch, please. So you don't really have qualifiers like public or protected or private. You can just make it more or less easy for someone to access something. But you do have a very nice way of handling getters and setters, which I absolutely love. So you can use, let's see, it's called a property decorator. So basically you do at and then property above your method, and then you will return the attribute and you prepend it with an underscore, because please don't touch this. But you don't use the underscore in the method name. So if you have like a car or color, let's go with color. So in your constructor, you do underscore self dot underscore color equals whatever you got from the whatever you passed into the class or the constructor. And then you have your getter, which you do at property def, so let's say color, and then you'll just return the underscore self dot underscore color, which means when you try to change just my object dot color, you can't, because that's a property and you can't change properties. And that also means that you can call, I'm not on video now, I'm doing like quotation marks with my fingers. So you can call quotation marks that method quotation mark, it's still a method, but you don't use the parentheses to call it. So you can use it as it was a normal property, but you've added the protection of that you can't change it from outside the class. But you can still access underscore color, but please don't, says Python and the Python developer. And the same thing for setters. So you have then you have to specify the property name. So you have at color.setter or setter.color. I can't remember at the moment. I think it's color.setter. Def also color. parentheses self. And then you comma value. So that's basically the value you'll assign to your attribute. And then you don't return anything, but you change the internal, or like the instance attribute of underscore color, like self._color with your new value. And there you can do all sorts of validations, etc. But when you use it in your program, you basically just do my object.color equals yellow. Kind of. I really like that use of decorators. Yeah, exactly that one.
Cool.
So then you kind of excuse the lack of
Privacy and
yeah, generally,
publicness.
so that's like double underscore. So that's I've never seen it used really. I just use single underscore because like, yeah, don't touch this and we're good. Because you don't really like it. Yeah, you can still access something without double underscore. You'll have to kind of use the class name, and yeah, it's still accessible. So it feels like it's easier to just indicate this is private, or rather don't touch this and use this interface instead, kind of.
Cool. Today I learned. Okay, so programming exercises, chapter 1. We made a fraction class in the chapter, and we kind of went through in the exercises. I didn't get through all of them. Did anybody get through all of them?
No.
No? Did anybody try to make a Sudoku solver?
No.
Yeah, I looked at that. I was like, I'm not going to do that. So I'll work through the exercises. Is there anyone that anybody wants to talk about before we get to it?
I just want to say I just didn't have the time to do the exercises, and so I'm a lurker at the moment. I'm hoping to do better next time.
No worries.
I second that and laugh as well.
This is why
from what you've been talking about, the thing that I would, I think I understood the self thing, but I'm sure I would get confused if I tried to make my own classes until I've. So any advice about how to better understand self, the use of self, would be welcome.
Kind of. So basically, self is something you'll use every time it's a instance method, when you'll kind of use the object within the method. Then you have class methods, which instead of self uses CLS for class. You can't use class because it's a keyword, so the convention is to use CLS. And then that will you'll have to use the decorator at class method to tell Python this is not an instance method, it's a class method, and then it will know the first parameter you'll use is the class, and then you can use the class name to call like not stat but class methods, or use the class in some way to check like what class is it or what type is it, etc. And then you have static methods, which basically have nothing to do with either the class instance or the class itself, but it's convenient to put them inside the class because there may be helper methods and it's messy to put them outside the class. It's basically a preference. And then you'll have to use the @static method decorator. And then you'll not use self nor class or CLS as your first parameter. Then the first parameter you use is something that Python will interpret as an actual value that you can then use in your method. But the difference between self is like, have I created an object? Like, or rather, every object is unique, but you can have class-specific attributes, which will be the same for every class. So for instance, cars. Okay, every car does not have 4 wheels, but let's say they do for convenience. So you can have wheel count equals 4 in the class. So you can access the wheel count from any instance, and just using the class name. But then you can have a specific car that maybe only has 3 wheels, but that's only for that object. Yeah, it's like yeah.
Basically, always use class unless you don't need to. But I at least found it super complicated when I first started doing it. I didn't understand why I needed to throw self in there a bunch of times. And so it wasn't until I went through one of those, like, I want to say it was the deck of cards example, which is very classical, like object-oriented learning thing, where I built that in Python. And then I was like, okay, now I understand when I need to do this stuff. But I think it's one of those things, the only way to get your way around it is like fail a bunch of times. And then
no, I get that. I mean, I think no, I think
I didn't find it intuitive at first.
I think in general classes, like you write all these toy examples, and then like most people coming out of these think they need to write classes for everything, and then it turns out you don't need to write all that many classes.
Yeah.
For example, I haven't written a really useful class in like forever in Python, but then like there comes a point when it becomes useful, but it's really far off in the future usually.
Yeah, so I think is that what you're saying? So when I do my scripts, I might write a function, a def, and a function, and that will do the job. To write a class and grapple with self seems like overkill.
Yeah, mostly.
Yeah.
Presumably the class writing comes when you're wanting to put together a bunch of stuff in a bigger project, maybe.
So, for instance, say that you want to manipulate or modify a existing object. Like a very useful one is an ordered set. So sets, you can only have one of something within a set, like 1, 2, 3, whatever. You can't have 1, 1. So you can only have, what do you call that? Like unique items. And they must also be immutable, because else they can't really be unique. So, and they're not ordered by default. Like on your computer, they can show up in some order, and then on my computer, they can show up in another order, and that may be an inconvenience. So then you can inherit from the set and implement all of these Dunder methods and make your set, like your custom, your sorted set or ordered set, to behave like a set, but it will also be ordered. So it's like it's super powerful.
Also, and I think when you like work from the functional viewpoint, the way you just try to do the abstraction and the reusing is just different. So like I can see why, for example, doing something like an ordered set inheritance would be really useful, because you're like, what do I want to re-implement everything that an ordered set does? I don't. Whereas like when you're used to like working in functional programming, you just think about it a different way, where you're like, well, I'll reuse the functions, and it's just a different way to like view it, the exact same thing from slightly different ways. But I'm coming around to object oriented the more I look at it. But initially, I kind of felt the same thing. I was like, I haven't written a class in years, except for the deck of cards was the last thing I think I probably wrote. Okay, fractions. So I will go through the programming exercises. So we define a fraction class in the chapters, and the basic idea of our fraction class, which is very simple, is that a fraction has a numerator and a denominator, and it represents a part of a whole. And the first couple ones are fairly simple to get your idea around it. So you implement simple methods getNum and getDen that return the numerator and the denominator of a fraction. These are my simple methods. They literally just return the objects. The fraction class starts here. This one's a little more complicated. I'm also going to put this on GitHub, by the by, so everyone can look at this. But basically, you have your initiator, and well, ignore that. It's too complicated for now. So this is it. Simple methods. We can verify that it works if we make a fraction object like this: fraction, numerator, denominator, 1/2 get numerator, 1 Get then. That's nothing. That's an error. 2. So success, really easy, knocked out of the park. Okay, and then it was implement all the Dunder methods, which here I have this little Dunder method thing. I had to Google actually what they initially were because I didn't recognize them right away. So I Googled them. I mean, sub, mul, I could guess. True dev, I had to figure out what it was. And then I had to remember how to multiply and subtract and add fractions, which made me feel like a 5th grader. But basically what I had decided to do, and please tell me if there's a better way to do this, is in all of these subtraction, multiplication, and true division things, what I did is I added these couple lines here where I first checked what kind of thing it was that I was trying to add or supply. So I did this with this is instance. So basically I've defined my sub function here, which will subtract a fraction. I use the self and then thing, whatever the thing it is I'm trying to subtract from my fraction. And I have these 4 lines of code here, which basically first checks if it's a fraction, or if it's an integer. So for example, if I'm trying to subtract 4, to make a fraction out of 4, you of course just make a fraction where your thing, which would be 4, for example, and then is on the numerator, and then the denominator is 1. So now you've got a fraction object, and you can subtract, multiply, etc. fraction objects as well. The second thing I decided you could subtract from a fraction was a float. So for example, if I gave the float of like 1.75, you can make that into a fraction fairly easily by basically taking your thing times 100, converting that into an integer, and then at the bottom you have 100. So for example, if you put in the float of 0.3, the fraction that represents that is 30 over 100. So that's how I decided we could do multiplication and subtraction. Then I decided the third thing we could deal with was fractions. I'm not going to do anything here. I just assign it to something called other frac. And then I raise a runtime error if it's any other object, because I've decided you cannot add or subtract or multiply any other object to a fraction if it is not an integer, a float, or a fraction. One thing I wasn't sure about, and maybe there's a clever way to have done this, is I found that it was a little bit repetitive for me, that I had to add this checking thing basically at the top of each of my Dunder methods. And I was wondering if there was a more reproducible way to have done that, like if there was a place I could have put in somewhere else.
Yeah, you can do a like check value or something as a static method, for instance, because you don't need like you only or as a, I guess, as a actual method, but you can use could not for use outside the class. You could make it private,
There might be more straightforward way, but maybe it's just wishful functional programming thinking. But in functional programming, you have to have this idea of type classes. Mm-hmm. So basically, types that implement certain things. For example, you can have the type class of things that can be added to things. Mm-hmm. I think there's something similar in OOP, but and in Python as well. I think there's a way to check if something has a method to subtract or to add it to something.
As attr.
So you could replace your checks with checking if the other thing is able to being subtracted.
Check if the other thing is, yeah.
So generally what you do in Python is you don't ask for permission. You just do it. And you think it's easier to ask, or it's easy to ask forgiveness than permission instead of looking before you leap, which you tend to do in many other programming languages. You basically do what you want to do, and then you check, oh, something blew up, let's handle that. So you try to do the thing you want to do, and you put inside a try block. And then, depending on the different exception you get, you'll handle it in different ways. But since we have a custom class, we kind of need to deal with that a bit further. That's basically what we're doing now. But
Right.
you
so
shouldn't,
So you could just try to do the subtraction and then accept. If it fails, just
you have this concept of duck typing. If it looks like a
Yeah,
duck,
right.
walks like a duck, quacks like a duck, it can probably be substituted for a duck. You can use it as a duck. So like, for instance, lists and strings are completely different in a way, but you can iterate over both of them. So in one way, it doesn't really matter if you have a list of strings with integers, if that makes sense, or if you have just a long integer, which is also a string. Okay, never mind. But the point is, you can use basically what you said, Yannick, but I'm thinking about the actual implementation. But you should definitely not have to repeat your code like that. Just like refactor it into something at least. And this instance is almost never used, I think, in production code. It's basically something you would use for debugging. I think, don't quote me. So it feels wrong, if that makes sense.
It feels wrong. Okay.
Yes, it's like yeah. And also you probably want to start doing other frac equals none outside of all over checks.
So
And then you can
like up here, other frac
yeah,
equals none.
you would yeah,
So
and
I'd
then
make
you
the
could
object first.
yes, so that would so it's nullable basically. And then you would do your try block, and then you can always like it depends.
But I'm not sure I'd want a try block here, because here
No.
I mean, right, we're specifying two separate choices. Either if it's a float, we convert it to a fraction differently than if it's an integer.
Yeah, I'm thinking you might want to have functions or methods that check like is int, is fraction, is, and then kind of column, like, I don't know, there's like some magic you can do with dicts, etc., to really make this simple. We don't have pattern matching yet. It's coming in 3.10. I'm super excited. But like the minimum is to refactor, yeah, like doing that one.
So I just Googled to find out if there's a way to check for the existence of a method, and there is. But one answer also pointed to something you said earlier, where it's easier to ask forgiveness than to ask permission. So he would just go ahead and try the thing and then throw an exception if it fails.
Yeah.
Okay.
Also, runtime error is probably wrong here. I would say value error. Also, in the feels category, it feels wrong.
Makes sense, yeah.
I think it's a value error.
I think value error makes more sense too. Let's see. Okay, so I'm not going to totally implement that. Let's keep this as a question mark about if instance is the thing. I'll post it as a question on Slack, see if anybody has like deep vibes.
Yeah, because if you like, you have the concept of truthy and falsy, of course. So none is falsy, and if none of those checks, instead of raising a value error here, like this is also like design. You could just like return, like skip that else altogether, and then just if you have another value, if you've like reassigned other frac, you'll have a truthy value. But if you haven't, and it's something you can't deal with, you'll have none, which is not true. So you can do if check type or if check value, and then do the thing you want to do if you actually have a valid value. Else you can, or you don't even have to do then you raise a value error, because obviously you have passed something you shouldn't.
So you'd say put the value error down inside of like the add method itself, rather than an additional function which defines first, checks the type, basically be like, if check type, do this, if, or rather, if other frac, do stuff. Something like
Yeah,
that.
I mean, or if is valid, or if is subtractable, or something. But yeah, I mean, both. Is that a good answer? Because you can absolutely do as you did. I don't know this answer. I'm just thinking aloud. So you can absolutely do what you did and raise the thing in like your deepest, most basic function or method. But it also feels good. I don't know. You should fail early and not silently. So it may be best to do what you did.
I think in terms of design,
Yeah.
what you did is the correct thing to do. It's not necessarily the thing most Python users would do. Because I'm seeing a lot of try and accept in, in my Googling. And I feel like there's this misconception that getting something to work is the same as getting something to work correctly. And a lot of people don't care, like they don't care enough about whether it works correctly. They just want to get it to work. And for this, try and accept is the best thing to do. Like if it works, it works. If it
will eventually get there.
It fail, but you never know if it fails in a different way than you anticipated.
I'm not going to finish fixing all this. But okay, so that would be something we could do, is basically rejigger this in some fashion. Right, so this is just kind of confirming that this will work. So you can subtract 1/2, you can subtract 1, we can subtract 2/3. I can't spell 2/3. Subtract 0.3. Able to do all these things. Multiply is essentially the same thing, works in the same way. The only one that I think is slightly interesting here is the way you can implement division. So if everybody remembers from whenever we all learned fraction, to divide by a, I really had to Google how to do fraction addition again. I was like, what is this? How do you do this again? To divide by a fraction, you flip it and multiply it. So this is, I think, the only place that basically is a slightly different one and is an example of how to use self. So for example, here we have already defined the method, the Dunder method for multiplication. So we don't have to re-implement this. What we can do is create a flipped divisor, is what I call it, basically. So you take your other fraction denominator and just basically invert them. And then we can, rather than re-implementing a whole new method for division, we use the multiplication on the flipped divisor. So here's another example of when you call self to call the class method. And again, this this works as expected, I think. So 1/8, 1/2. Hopefully we get 1/4. Okay, then implementing the remaining relational operators. These are the ones I had to Google what they were. Greater than or equal to, less than or equal to, and not equals. So these are all, it's relatively easy to implement these as well. Because once you have, as Yannick said earlier as well, once you have one of the methods implemented, you kind of have all the other implementations as well. So if you have equal and less than, which I didn't con on to, that you could just do the 2 and then keep reusing them. So I did all the math for fractions. When is a fraction bigger? How do you compare a fraction? I won't go through all of them. Let's see. So, the one other Dunder method I will walk through is the right add method. So the idea with the right add method is basically, I had defined that this will work but until I define the right-hand method, this equivalent would not work because it would see the right-hand side, it wouldn't know. Basically, it's, I don't know exactly how to describe it, but it's saying pay attention to stuff on the right-hand side of something. So here we're going to use the method from 1/2 rather than trying to use the addition method from the integer 4, which returns this fraction.
This is basically calling Dunder add on the integer class, and that does not know how to add a fraction to it. So that's why you need to use the right
addition
and as
method.
well. I had a very annoying bug with that one time.
This is the in-place add method, and for whatever reason, I couldn't get it to work properly with my function class, and it could be that I just made a really silly error. So let's say come back to this one later when I actually implement that. I didn't actually do this. Okay, and then representation versus string, we talked about that earlier. This is basically, this is for the users, pretty, and this is for the developers, ugly.
Informational, informative, or whatever. Yeah, useful.
And then logic gates. So I'm gonna say we stop here because I wanted to have these meetings be about an hour. And
sense.
usually everyone's attention span tends to stop at a certain point. I'll also figure out how to stop recording. It'll speak. Ready?